My name's Andrew, and this summer I'm interning on the Red Hat Ansible technical marketing team. This is the first installment of an intern's guide to Ansible. I'm making this guide because I know that Ansible can be pretty intimidating at first. And now that I've started to get the hang of it, I want to show other people that it's actually pretty manageable. In this first episode, we're going to be talking about Ansible, what it is, and how it relates to system design as a whole. Ansible is a tool built around a concept called infrastructure as code, which means that it expresses infrastructure configurations as human-readable files that can be versioned, reviewed, and reused instead of having to make changes by hand every time. Imagine you had a big server room and needed to install a package on every single server. Without Ansible, you'd have to SSH into every single one manually, install the package, edit config files, restart the services, and repeat for every single one. This works fine for one or two servers, but when you have enough of them, this gets really impractical. That's where Ansible comes in. Ansible will SSH into each one automatically, run a given set of tasks, and report whether the system changed, without you having to lift a finger. This is a critical part of modern web infrastructure today. A common workflow with a lot of infrastructure as code looks something like this. First, Terraform creates virtual machines, sets up networking, storage, etc. Terraform decides what infrastructure is going to exist and how it's going to be structured. Next, the responsibility is handed off to Ansible. Ansible installs and configures software such as container runtimes, monitoring agents, or components used in a Kubernetes environment. Wait, what's Kubernetes? If you didn't know, Kubernetes, which is the foundation of Red Hat OpenShift, is a platform for running and managing containerized applications at scale. Kubernetes organizes machines into a cluster and schedules application workloads, packages pods, onto appropriate nodes based on available resources and any placement rules that you define. So now that we know how Ansible fits into the greater scheme of things with software infrastructure, we can get into how you use it. I mentioned earlier that Ansible SSHs into each machine and runs tasks. The way Ansible determines which machines to automate is via an inventory. Your inventory will have a set of machines which we call hosts, which can also be put into groups, referenced by their IP addresses or host names. Inventories can be sourced either via file or by a different dynamic source. Once Ansible knows which machines to access, the actual tasks are defined within a playbook. Playbooks are written in YAML, a human-readable configuration language used very commonly in infrastructure automation. Within a playbook, you can define one or multiple plays. Essentially, every play identifies a specific group of hosts and outlines a sequence of tasks for them. You also have the flexibility to add names, specific variables, and settings like privilege escalation or handlers to customize how your play executes. And your hosts are pulled from the inventory that's referenced when the playbook is run. Variables are very helpful when there are environment differences across your hosts. They're referenced within your tasks with Jinja templating syntax. Tasks are the heart of the playbook. These are individual operations that use specific modules to do things, such as install a package, update software, or spin up infrastructure. Now, most of the modules you'll use in Ansible are built around a really important concept called idempotency. An idempotent task just describes how you want the system to look. And if it's already in that state, Ansible won't change anything. Idempotency is awesome because it means you can run a playbook over and over again without worrying about making accidental or redundant changes. Just keep in mind that idempotency depends on the specific tasks you're running. If you're just running random shell commands, for instance, they won't be idempotent by default. Idempotency is achieved through declarative syntax. Instead of saying sudo dnf install nginx, we can say state present. This means that all Ansible is doing is making sure that nginx is present. So if it already is present, we can safely skip it. Same goes with making sure something's not installed. We can just use state absent. Andrew, what happens when a developer executes a playbook from their laptop using certain collections and versions, but the automation server uses something entirely different? He's right. Without consistency, that same playbook might act up or just break because the runtime isn't the same. Execution environments solve this by bundling Ansible, your collections, Python libraries, and all the other necessary tools into a single container image. This makes sure your automation runs with the exact same toolset every single time, no matter where it's being launched. Execution environments are typically built using the Ansible Builder command line tool. Dependencies are defined in a file called executionenvironment.yaml, where you specify things like Ansible collections, Python libraries, and supporting tools. Then, Ansible Builder packages everything into a reusable container image. Traditionally, you can run an Ansible playbook by typing Ansible playbook, using -i to pass an inventory file, and putting in the names of your inventory and playbook files. With execution environments, though, you can use something called Ansible Navigator. With Ansible Navigator, you can select an execution environment image through a configuration file, such as ansiblenavigator.yaml, or through environment variables, or directly on the command line. Once you configure the Ansible Navigator file, you can run Ansible Navigator run your playbook, optionally providing an inventory, and Navigator will run the playbook using the execution environment you selected. I hope this is a good introduction to the basics of Ansible. Next episode, we'll be going over Ansible Automation Platform 2.7, how it simplifies automation workflows, and how organizations use it to manage automation at scale. As always, have a great week and happy automating.